All right. Hello, everyone, and welcome to the stream. I hope everybody is doing well tonight. We are going to pick up where we left off last week, plus a little bit, because I did get a couple things done offline that we'll discuss here momentarily. But we are going to continue with some of our gameplay systems tonight, our game-specific code. We'll kind of get into that in just a minute here after I give credit where it's due. So I do want to take just a quick second to thank the supporters of the channel, beginning with our elite partner, Javier Olazaran, followed by our partners, Gribbles Inc. and Matt Osgard. They are the highest tiers of subscription over on YouTube memberships and Patreon, followed by the list of supporters you see here on the screen. Scrolling by, they are a combination, of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for that support. It is greatly appreciated and is going to, or it does rather, help me cover the cost of running the channel. Things like software licenses, hosting fees, and soon to come assets. So thank you all very much for that support. It's greatly appreciated and helps me out a great deal. Of course, I would be in error to not give a big thank you to all of you, the viewers, whether you're joining me here live on the Twitch side or the YouTube side. Without you guys, this project and this channel would not exist. So thank you guys for being here. I appreciate each and every one of you guys. What's up? You are indeed first. How's it going? Good to see you, buddy. All right. So, I guess first off, we should probably talk about some of the things that I got done off camera. It's not a whole heck of a lot in terms of code, actually, because a lot of the systems that we've been building up to this point have actually come quite a far way in assisting us to, be able to easily stand things up in our games, our gameplay systems, rather. So before we had sort of the ability to walk around, and we kind of had that sort of hard code hacked into our game logic. And so I've added a couple more states. You can now walk backwards, which also just plays the walk animation backwards for now. So we know that our timescale stuff is working. We'll get into that in a minute. We also, if you press the shift key while you move, you go ahead and run, right? So there's a running state as well. And then there's also a jumping state, which can be done from standing still, walking, or running, right? And I do realize that the animation there is a little bit wonky, but we're only using a temporary placeholder asset, right? So when we go ahead and make the real asset for this, we'll be able to time things a lot better. So in this case, the jump animation is actually the jump and the land kind of all in one. And ideally, we'd have those as two separate animations with maybe a falling animation in between. And that would allow us to time the states better, as well as being able to pick up movement and things like that. You can see here it's a little bit awkward, right? But this is what we have for now, so this is what we're going to go with. In addition to that, now if you press the F key, you can actually attack, and it plays a little bit of a sound there. And I have the sound hooked up, so you guys should be able to actually hear that this time around. So we've got that, and then of course you can interact with other entities within the scene. So this is a sound emitter right there, so you can kind of hear that panning back and forth. And then, of course, there's the ability to teleport to a different scene, which we don't have set up right now, but the ability is there. So what we're going to take a look at is how all of these states are handled, and how we actually make sure that we don't enter the wrong state at the wrong time, right? So with that, let's jump into it, although I will take a quick second just to catch up with chat before we do. Pretty water nice. Yeah, it did come out pretty nice. It'll look a lot better when I have stuff like underneath of it to refract as well. So at some point I'm going to be putting in some assets just to kind of make it look a little bit more like an actual scene, even though it's just kind of test stuff for now, just kind of feeling systems out. Sergeant Pepper, good to see you as well. Fatalities when? Do you mean like a death animation? We actually do have that. I don't have the state programmed in yet, but at some point. Unless you mean the Mortal Kombat fatalities. That's a different story. Okay, so let me actually first go over the state, the state machine, right? So avatars, player. So most of this will look kind of similar to what you guys saw in the last stream, although I've made a few modifications, right? So we have our idle states, our walk state, our walk backward state, states rather, run, jump, land, and then attack with a sword, attack unarmed, and attack ranged, right? And these are all, most of these are actually hooked to an animation. With the exception being, well, I guess land actually does as well, but we'll get into that in just a minute. So the biggest piece here is, I don't know if we had the walk backwards last time, so that one's new. The run is new. And the jump is new as well. So we put in the transition states in there that we can transition from. So we have all those hooked up. I fixed a couple of bugs regarding that as well. So all of those transitions actually happen correctly now. I know we had some issues with that on the last stream. And so these are all the various states and the animations that play when you're in those states and so forth. So this is actually pretty much where we want it to be as far as expanding things. The other thing is the player avatar, or avatar player. Yes. So we have a number of functions defined here. Some of these we're probably going to get rid of because they're not all necessarily used, but I wanted to define them. So all of these functions, because of the way they are named, they are automatically loaded and hooked up to our avatar system just by their name, including hot reloading. So all of those things work just fine, and they work according to what we had in the last stream as well. We've just added a lot of other functions. So there are two levels to this. So there's the player avatar, and then there's sort of this overarching sort of player that manages the player avatar. And that is kind of what I'm going to talk about tonight, at least to kind of catch you guys up as to where we are. So the player itself has essentially a player state, which if you take a look at that, just includes a bunch of things that we need to actually manage the player. So we've gone ahead and cached all of the animations, or all of the state names rather. We keep a pointer to the avatar there, and then some speed multipliers. We've also kept some of our resources here. This will matter more in the future once we get into battle mechanics. And then serializable state, and then we have a hack here for a test sound. We're going to come back to that. So this is kind of where all of that type of state stuff exists, right? And so I've created this new player H and obviously C file. If we go to here, we have this new this new folder with these files in here, right? And so essentially the way that we do this is we want to use the player state to manage the player everywhere possible. The player state is the ultimate source of truth for all things player, right? And so I might rename this, instead of player state, I might just rename it player. I haven't really decided yet. But player state was sort of the name of the structure that we had in place, so I just kind of used that. So there's initialize, which is pretty self-explanatory. Spawn in a particular zone, so that takes the player a zone ID and then a spawn point ID. To be able to move to a particular location and rotation within a zone. And then we have just a couple of few state checks here, whether the player is jumping, whether the player is attacking, and if the player can move. And the reason that those are functions will become apparent here shortly. So the other thing that we have here that I want to talk about that I kind of skipped over is actions, right? So player requests action. So the difference here is whenever you press a key on the keyboard, or whether it be a key on the keyboard, a button on the mouse, a button on the controller, whatever it may be, ultimately what we're going to do is we're going to say we want to execute an action, right? And that action may be walk forward or sprint forward, or turn left, turn right, jump or attack, interact with something, whatever that may be. And so the player action will help us essentially say, this is what we want to do. And then we essentially query the internal state to see if we can do that thing or not. And so we have this function here called player request action, where we do just that, right? We say, I want to actually execute this action. And then depending on several things, including what state the player itself is in, right? The player state and the player avatar, determines whether or not we can actually do those things. And if you can, it will. If it can't, it just won't, right? And that's sort of the layer of separation there. So if we take a look at initialize, so this is essentially where we say, okay, this is where we're going to load the player avatar, right? So we load up that asset. We go ahead and we create from config. I just realized I'm not releasing that asset, I don't think. So we need to do that. Asset system release text. There we go. I guess I'll just do an engine. You know what? I think I want let's just do this. Engine system states. Systems, and we'll just do engine systems get. So we only query that once. And then we can just do states like that, or systems rather. So we'll need that. What is, oh, it's const. Right. Okay. So we need to release that. So we're going to say systems asset states, and then the asset itself, which is just going to be that, right? So we go ahead and we load the text asset, which is this avatar.player, right? So that reaches into the manifest, says where is this file, or where's the asset, name this thing, and that loads this player case and file, right? So to that, we go ahead and we say avatar create from config, and that's what loads up all of that KSIN. We already did that on a previous stream, so that has not changed. And then, of course, we release that particular asset. The other thing that we do is, and this is something I added off camera as well, is we register for an event called animation complete. So our model system now has something in place. Animation complete. There we go. So our model system now has something in place where if the animator is not looping, we'll basically say if we've reached the end of the animation, we're going to go ahead and just fire off an event that says, hey, we've completed this animation, right? I did add a code for animation started, although I haven't actually hooked that up yet because I don't know if we're going to need it or not, but it's there. So this essentially passes along the kname animation name as the first U64 within the context, right? Same for this guy. So we know what animation actually completed, right? So we register for that, and that's go back here, and that is the player on event. So we have up here, whenever we complete an animation, we just check what the animation name is, and then depending on that animation, we may do other things. So we'll come back. We'll come back to this in a bit. I've got a to-do here to kind of figure this out a little bit further. But essentially, the main thing is here is when the jump animation completes, we transition into a land state. Otherwise, if we have one of the attack animations, which is punch, sword slash, or shoot one-handed, then we just say attack animation is complete, and we switch back to the idle state, right? So that is the primary use for that. That way we don't have to worry about trying to time it and line it up with the animations and all this and that. We can just simply go off a trigger that says when the animation's done playing, switch state, and it just works. So that's that. We go ahead and set up all of this stuff that used to be sort of in the global game state is now in the player state. We go ahead and create the K names for all of these state names so that we don't have to constantly do those within our render loop, because that's kind of a costly operation to do it in line like that. So we cache those. And then I've got a bit of a hack here. We're going to come back to this with a test sound that I'm using to play along with the attack, right? So that is just, if I go here and load this up, when I press the F key, it's just that little sound, right? So we'll come back to that. Now, the meat and potatoes of all of this, what really drives how all of this works, is the player request action. And so we've got obviously a huge switch case here for the different action types, and this will expand as we have more actions. But these are player-specific actions, right? Which eventually will model to various control schemes that we'll have set up in the game, depending on where you are in the game, whether you're in a menu or whether you're in the world playing or what have you. But for right now, the only one we have active is player actions, right? So that's kind of a specific thing for the player, right? So in the idle state, we want to first do a check, can the player move, right? And if they can, we'll just go to the idle state and then go ahead and turn the animation looping on, right? Now, this player can move is a utility function down here. We've got a couple of them. And essentially, we do a quick state check on the player avatar, right? So this is made up of the players jumping and players attacking, right? And it says basically if we're not jumping and we're not attacking, then we can go ahead and move, right? So players jumping is basically saying, is the current state name the jump state, or is the current state name the landing state? So once we have a falling state, that'll be in there as well, right? So is jumping will include whether we're currently jumping, falling, or landing, right? And then is player attacking, right? Just basically says, are we in any of these attack states, whether it's unarmed, sword, or ranged? We'll probably have more of those as well. And so that is those state checks, right? So those are used in a lot of cases, right? So we don't want to allow essentially a transition or a request to idle if we are not able to move, right? Because that means that we're jumping or we're attacking, and we shouldn't go to idle in the middle of those things. Sprint forward, as you can imagine, we need to be able to move to do that, right? So if we can move, then we can go ahead and say, go to the run state, and then change the looping to true. We're always setting this looping to true because we have some states where that is false. So we'll get to that in just a minute. Walk forward is pretty much the same thing, except instead of running, you're walking. Walk backwards is just walking, but backwards, right? Pretty self-explanatory. Turn left and turn right. You have to be able to move to do that. So again, you can't turn while you're attacking. You can't turn while you're jumping. That kind of makes sense, right? Jumping is a little bit special, right? So jumping, we have to be able to move to do that, right? So if you're already jumping, you're already landing, you're already falling, which is another one we're going to add. If you're already attacking, right, then you can't jump. So all we do here is we transition to the jump state, and then we carry over the velocity from the pre-jump state. So this is kind of important, right? Because if we were standing still when we jumped, we don't want to be moving anywhere, and we don't want to be able to, start moving midair. if you were walking, we're going to maintain that momentum going forward. If you were running, we're going to maintain that momentum going forward. Same as if you're walking backwards, right? And so just to illustrate that, and I kind of illustrated this before, but if we jump and I press on the W key while we're in the air, it's not going to happen, right? If we are walking and we jump and I let go of W midair, it continues moving forward until we're done with the animation. Same goes for jumping, right? So that's the difference there. Although it looks like our backward state might actually be busted, so I'll have to look into that. But there we are. Okay, so here's the attack, right? So actually, why did I separate these out? Because these are the same as can move. Not jumping and not attacking. So actually, let's simplify this, and let's also make this player can move, right? Because there's no reason to check those separately, because that combines those two checks. So you can't be currently jumping or attacking in order to attack, right? It just kind of makes sense. So in this case, what we do is we transition to the idle state first. And then we go ahead and immediately transition to the sword state, right? So this basically kind of resets the animation or whatever it was that we were doing. And then when we go ahead and switch to the attack, which this here eventually should be depending on what weapon we've equipped. I've chosen the sword attack here. Obviously, that would be one of these three, right? So we've got that, and then we set looping to false, right? Because we want to play the attack animation once and then go back to the idle state, right? And then the other half of this is we have a hack here just to play the test sound on channel 1. And this is kind of what we're going to address tonight. And then we don't do anything for the interact because we don't have anything to interact with. So that is mostly it. Everything else was us basically hooking the zone stuff up and the scene stuff up to the player, right? And just getting notifications on those things. Most of that I feel is pretty self-explanatory. I think we even talked about a lot of it in the last stream, so I don't know that I'm going to go over that. But anyways, I think that's us caught up, except for the sound stuff, which we're going to talk about next. So let me take a second to catch up on chat, because I know it's been a minute. Sergeant Pepper, you want to pull somebody's spine out of their back? That'd be pretty epic, right? Is it a cue, an action cue? No. So the action cue, we are going to have an action cue, actually. But that's going to be a separate thing. So we're going to have actions and then action. We're going to have an action cue. And that's going to be a higher level system that ultimately calls this. So an example of an action cue is, let's say, for example, we want to, I don't know, use a ranged attack, right? From a crossbow or something like that. So that would obviously have several actions that you would need to take, right? You would obviously need to make sure that you could even take that action. So you'd need to have some sort of state check. And then after that, you would have to say, okay, I want to kick off this animation. And then I want to deduct an arrow from inventory. And then I want to maybe spawn a model of an arrow in the scene. I want to create if it's like a firebolt or something, I want to create a little bit of a light source in the scene, spawn one of those. And then I also want to maybe spawn a sound emitter that travels with it. And so forth. And so you could have a very linear set of things like that. And then you could also say, player action shoot or something like that, right? So this would sort of lay underneath of that, I think. And we might even have something on here where instead of just doing a player request action, we might actually have a player can perform action that returns a Boolean. So we'd have some of these cases where it would say, okay, can we actually do this thing? And then do the thing in a separate step. I think having a trigger event in mid animation would be better, like for frame data, hitbox, hurtbox, play sound effects. That's another way of doing it. Yeah. So you could certainly attach that to the animation, right? And have some sort of trigger that gets called similar to how our completion gets called. We could have some sort of event code for that and have some sort of way to say within the animation, fire off an event of some sort, right? That would certainly be something that we're going to need that at some point. So that's definitely one way of doing it. But the other stuff like checking to see if we can do it, removing from inventory, all of that kind of stuff, I don't know that I would necessarily, well, technically speaking, thinking about this, if we have an action queue that says request that the player shoot a crossbow, right? One of those actions in that action queue could be wait for an animation trigger, right? So you would essentially have start the animation, wait for a trigger to happen. When that trigger happens, then that action's complete, and then it can continue down the queue of those things. So technically, you could have the best of both worlds that way, which is actually, now that I think about it, probably the way to do it. I'm just going to have to figure out how I want to manage those triggers in terms of our file format, because we'll have to add that, which is not a huge deal, but we'll have to add that to our file format. Penguin Operator, good to see you as well. Okay. But what I'm going to tackle tonight is something that's actually been kind of bothering me for a little bit. So here we're doing a complete hack, right? We're loading up a sound, and then we're basically just playing that whenever we fire, or whenever we attack, rather, here. And so the way that this really should work is we really ought to have something, and again, this is something that could probably work off the back of an animation trigger, right? So that when you get to a certain point in the animation, that's when the sound plays, but we're not there yet. But essentially, what we need is a centralized way to manage audio, right? Because I don't want to have to do all this. I don't want to have to, like, the player should not own this sound, right? Because this right here is basically going to give us a audio instance of a sound, which is fine. But we might have the player might play this sound, and then we might also have an enemy that needs to also play this sound, right? And they each need to play that sound at different times from different positions and all that stuff. And it doesn't make sense for the player to own this, right? And this was definitely just a hack, right? That's why I put this big thing here. Ideally, what we should have is some sort of sound manager that has, say, a list of sounds that can be triggered, and those sounds be preloaded. And then whenever we need to play one of those sounds, we just say, hey, sound manager, or sound whatever we call it, go ahead and play the sound that's called this thing. And then we don't have to worry about it, right? So there's two things that we would have to do there. We have to have the ability to just play a sound from like a static call anywhere, right? A 2D sound, which is something that we're going to want. But we're also going to want the option to play that sound on a particular emitter, right? And we do have audio emitters in our scene. And so like this was, I'll show you an example of that. So we do have, I should probably move this a little bit closer, but that's what this orange sphere here is, right? So we do have an audio emitter, right? And so the idea is that we would have one of these things that essentially follows the player around. And it won't always be playing a sound, but we can at any time basically say, audio emitter, play this particular sound. And the reason we want it focused on the player is because if, for some reason, we decide that we want to pan the camera or do something with the camera where it's not necessarily centered, right? We want to have that spatial sound ability. We also want to be able to apply effects to it, like reverb and stuff like that if you're in a cave. And so a sound emitter is going to be the way to go there, versus the way that we're playing it here, which is kind of just a 2D method of playing it, which isn't necessarily right. So yeah, there's a couple things that we need to do here. We need the ability to say, for a particular emitter entity, we need to be able to set the sound on that. And then we also need the ability to get said sound from a board, and then also play one of those sounds in a sort of 2D way, which is basically saying play them over both stereo, both channels in stereo at once. And so I'm thinking, like, we do have our audio system, which is kind of our low-level audio system, where we can be very explicit about how things are set up. And I think we just need something higher level that we can access from the game. And so for right now, I'm going to create this system in game code. I suspect this is probably going to wind up moving to the engine, but we'll see. All right. So what I'm thinking for that is we do have systems in here. So I am thinking that we're going to need a, what do we want to call this? So Sound Manager could work. I don't really like managers though. Like, what do we call this? Soundboard, maybe. Sound player, yeah. I'm thinking soundboard, right? Like one of those things where you could literally just hit buttons and play sounds, right? Although this will be a little bit more. This will be a little bit more functional than just that. Frozen Shadow, how's it going, mate? Good to see you. Roadie, Sgt. Pepper, that's funny. I would do that, except 90% of people probably wouldn't get it. I guess let's do. I'm gonna go with soundboard. All one word, underscore. Probably overthinking this. I'm gonna go all one word. And we'll do a C file. All right, so pragma once, right? So we're going to have a number of things. So first off, we need a state. Struct soundboard state. Sound. God, I can't type tonight. Board state. There we go. And this basically is going to need to have, we want to reference all sounds by K-name, which means we're going to need a quick way to look that up. So I think probably the best way to do this is we're going to have a K-audio instance array, right? We're going to say Oh, can we even do that, though? No, I don't think we can do that. We actually need one more thing. We need type def struct soundboard entry. I guess I can rename it later. Soundboard entry, right? And then this contains, I guess just for troubleshooting purposes, we'll put the name here. But then we'll also do, let's do kname asset name, right? Because we could potentially call the sound something different than the asset name. And then we'll do kname package name. And then the instances. Are we ever going to need more than one instance? I'm thinking yes. Because we could potentially have the same bass sound being played multiple times at the same time, but at different times. Like one could start playing while another is halfway done, kind of thing. So I guess I'll do, how do I want to do this? Instance counts, and then audio instance, instances. Right. And essentially I guess we could probably make a pool of this. Right. And then for each one of these things, we could say whatever the max instance count is, how many of these are in use, etc. Which we actually do have a pool available for that. At least I think we do. Pool allocator. I don't know if that's what I want, though. Allocating free. We might be able to use that. Because I can also set, I could, I guess, set the memory. Do I want to mess with this, or, because this kind of has a, I don't really need everything that this does. All right, let's do max instance count, instances, and then we'll also have, I hate to do this, but I guess states, right? Like U8, or I guess it would be B8 states. Right? So true equals taken, false equals free. Might be able to pack more data in there if we need it. So my thought is, for each one of these soundboard entries, we can say, okay, I want to create a new soundboard entry called this. It uses this asset and package. Here's the max number of instances it can have. And then we essentially treat these two as the pool. We loop through them, say, hey, where's one of these that's free? Return that audio instance. and then mark it as taken. And then when we release it, we can flip that flag, right? So anytime we either play a sound on the soundboard, then we just internally grab an instance of that and play it. Or if we request it to be put on a emitter, we'll grab that instance, and that'll be taken until we manually release it. And then we can play it as many times as we want, or switch it out, or what have you. Yeah, I think that's going to work. Let's see. Oh, I've missed some chat. Okay. Just did a whole day's worth of changes to address like 25 pull request comments, and I only broke 2 tests. Nice. Psycode, good to see you. As a programmer, do you always separate your data structures from your functions? For example, keeping things in simple structs. How do you stay organized so you don't lose track of where functions belong or end up messing things up? Well, yeah, C doesn't have member functions, so that helps. I don't really have a choice. I mean, I could use function pointers, right? But that's not really all that useful for the vast majority of things. So yeah, like Psycode says, you just kind of organize them in the context that they're used, right? So we're setting up this soundboard thing here, and I'm just kind of trying to figure out the data here. But all the functions for the soundboard will be in sort of this same file. And then any other systems we interact with are kind of set up the same way. So it's not really, there's not really much to it. Yeah, so I mean, I guess you're about to see an example of how we're going to do that. So, all right. So we have a single soundboard entry. So now what we have here is, I guess we'll do let's do a D array. We're going to do soundboard entries. And I'm going to do this as a D array because I don't see the need to manage it otherwise, right? This is one of those cases where just setting up a D array makes sense. The other thing I'm going to do is a U64 BST, right? And I think this is BST node. What is that? U64 BST. What did I call that again? BT node. So we'll do BT node. And we're going to do lookup. Right? And so this is going to be a lookup table of kname to entries. Right? So we're going to use this binary tree that we have as a lookup. And as it so happens, and this isn't by accident, our binary tree uses unsigned 64-bit integers, which is also how our knames are represented, right? Because that's a 64-bit hash of a string. So it lines up very nicely with this and allows us to get quick lookups without having to scan this entire entry listing, right? Scanning this and going in and saying what's the name of this isn't a big deal if you have, say 20 sounds, but if we have significantly more than that, having some sort of lookup structure is going to be helpful. And I suspect we're going to have many, many, many of these. Binary tree, why not hash table? I don't have a, well, I do have a hash table, but it's kind of crappy if I'm honest. And like I said, I don't really need the hash table because my key is always going to be an integer anyways. The hashing is already done in the kname, right? So kname is basically we take a string And when we create a kname, we create a hash of that string, which is a U64 integer, right? A U64. And then we also internalize that string into an internal lookup table, so that we can also retrieve the initial string. But that keeps us from having to pass strings all over the place and use them in places like hash tables, where I can just say, now our name is represented by a number that's quickly lookupable in something like this. You would expect 100K sounds per frame. Yeah, I know, right? Binary treason. It's funny. The psychopath is going to need this function. The psychopath knows where I live. Where should I put this function so the psychopath doesn't kill me easy? That's one way of looking at it, Sergeant Pepper. Okay. How do you keep all memory allocations without having memory leaks in C? You're so used to C++. I mean, it's just managing that stuff, right? But like, we have custom allocators that manage a lot of that stuff for us that we've set up. So I've got essentially a large arena of memory that I create when I first launch everything, right? And then I dynamically allocate out of that. And I've got that split up into subsections that can be used for different purposes that are optimized for different things in terms of how memory allocated and all that. But essentially, we basically create this huge allocation and then dole out allocations to the rest of the system out of that huge bin. And what that means is when I go to shut down, I don't have to worry about releasing a whole bunch of memory or anything like that. And I can also tag and track those allocations myself. So if I don't have allocations being freed somewhere, I actually know exactly where those things are happening. If you never allocate memory, then you never have a leak. True. I also try to avoid doing mallocs whenever I can. And I use things like frame allocators to my advantage, right? That get reset once per frame. Okay. So let's see. We have a lookup and entries. Do we need anything else right now? I don't think we do. I think we can actually start based on this. Okay, so let's go ahead and do, and because I suspect that I might be moving this to the engine, I'm going to export this symbol. And I'm going to do void. I guess I could do, is there any reason this initialization should fail? I don't think so. Okay, so let's do soundboard initialize. And I think the only thing that I'm going to do, you know what, just in case, let's return type boolean, right? And I'm going to do a soundboard states out states, right? And then obviously we're going to have a soundboard, if I can spell it, destroy or shut down, I guess. And that's going to be soundboard states, oops, state. All right. So your basic initialize shutdown. I don't know if we're going to need a update loop for this or not. Let's see. Is there going to be any sort of state that we need to update once per frame? I don't think so. We'll add it if we need it. All right. So the next thing is going to be, we want to do a B8, and we're going to do soundboard. I just thought of something, but I'm going to keep that. We're going to come back to that. All right. So we're going to do that soundboard, and then we'll do add entry. I guess we can call that for now. Soundboard states, and then we're basically going to pass a lot of this stuff, right? So kname, name, kname. Let me get rid of this stupid browser over there. So kname assets name, right? Because we need to know what we're going to load. Package name. And then we're going to do, you know what? Our max instance count does not need to be that high. Let's go with U8 on that. Max instance count. And then, actually, I think that might be it. Right? So essentially what we're going to say is when we go to, I'm actually just going to kill this tab for a second. When we go to add a new soundboard entry, we're basically going to load up an asset and say this is the max number of instances that we can have with that asset. And at that point, we'll go ahead and create all the instances that we need. And we want to be somewhat sparing with that, right? So creating audio instances does take resources, right? So we don't necessarily want to always make this a gigantic number, right? In most cases, you won't need more than, say, 2 or 3 instances. So that's what I'm saying. It should be a fairly small number. We're not going to have the ability to delete entries because I don't think we really need the ability to do that. I don't think we need to manage this on the fly. I think once something's added to the soundboard, it's always there. It's always available. The next thing is going to be, we're going to need a couple of points to interact with this, right? So we're going to do kAudio instance, and we're going to do soundboard. I guess we'll say entry. We'll say entry instance get, right? And then we'll do soundboard state. Oh, you know what? We should probably do this as a Boolean. Come think of it. So we'll do state and then kname, right? So the name of the entry. And then we're going to do the kAudio instance out instance. And that's because this can fail, right? So if the pool doesn't have any available instances to return, then we obviously need to fail that, right? So this is going to be used for things that need to maintain, used when the instance needs to be maintained for a period of time. Must be released via soundboard entry release to be used elsewhere. Good enough. All right. So with that, obviously, we're going to need a release. This one, during release, if that fails, there's not really anything we can do about it. So I think we're going to do release. And you know what? Instead of get, I'm going to say acquire. Because that's kind of the verbiage we've used elsewhere. So let's see. kAudio instance. I guess we are going to need the name and the out instance for this as well. Part of me wonders if we should have those grouped together in a struct so we could just pass it back and forth and not have to worry about maintaining both. I kind of am leaning more towards that, right? Just in case we need to add anything to it. So type def, struct, soundboard, direct flare over on the YouTube side. How's it going? No, I'm a little late to your message there, but I did see it. Kind of in the code flow state tonight, I guess. Allocators. Yeah, exactly. Dr. Elliott, how's it going? Good to see you. Let's see. I guess we want to say soundboard. Entry instance or entry. Yeah, entry instance, I guess, is fine. Soundboard entry instance. right? And then we can say kname entry name and audio instance audio instance. Sure. Okay. So we can do, instead of that, we will do audio or soundboard entry instance, right? Then we'll do that here and get rid of the name, right? So to retrieve one of these, we do need to pass a name separately. Technically, we could pass it here and read it out of there, but I think that's a little bit not as nice. So essentially, the name that's provided here will get copied over to here if it's successful. Why is my... Okay. And then when we go to release that thing, all we need is a pointer to the instance. The reason we are taking a pointer to this is because we want to invalidate this after it's been released, right? So we want to go ahead and release that. And then, so that's going to be those two. And then the other thing is we just want the ability to say, hey, I just want to play this sound. And that's it, right? So let's do KAPI, and we're going to do, I guess we could do a B8 to report a failure. I don't know that that's going to be valuable, but entry and then play. And all that's going to do is do soundboard state, and then kname name. So all that's going to do is basically just quickly play a sound, and it's essentially going to run this procedure internally, but automatically. And you don't have to necessarily manage that externally. And that, I think, is going to be the entire interface for this thing. Now, I feel like it's kind of a pain in the butt to have to do all of this in code, right? To just basically call this a whole bunch of times and create all the K-names and all that crap. When I feel like we could probably have some sort of configuration for this that we could load. That's just a KSIN file that could do all of this for us. So I am going to put that as a note up here at the top. To do configuration for this system that allows a KSIN file to be created that includes entry configs for ease of use. And what that's also going to allow is it's going to allow us to expand our soundboard without having to recompile. Maybe I should just go ahead and do that now instead of... Yeah, I think I'm going to do that now. So let's put that in here. We're going to do, we're actually going to do a string, right? So we're going to say constant character array config string. And we'll just parse that on the fly, right? So if it's provided, we'll parse it. If not, you know, the player can always just do this as well. No entry stop. I suppose that is a good point, right? We probably, maybe we could have, I didn't think about that. That's a good point. We should probably also have like a pause resume feature too, right? I guess. Which is a little annoying because our audio system already does that, but this is like a nicer interface to go through that. So I feel like it'll just kind of pipe a lot of that through. So like maybe we do, whoops. Oh, wait a minute though. So we don't actually have a handle as to when this is actually like to the internal instance, right? I was trying to avoid that. So like when we say play, that's fine. We just kick one off. Internally, we manage all this stuff, right? But when I go to say stop, I have to have the ability to say which one do we want to stop, right? Because I'm not going to know internally, well, is it an entry that was kicked off this way, or is it an entry that was kicked off this way? Which instance do I stop? So I could do the whole out instance thing here instead of a Boolean. But there's a couple problems with that. So if I do it that way, yes, you'll have the ability to stop it. You know what? I'm going to say it this. If you need the ability to stop it or pause it, you need to just do it this way. And use the K audio instance with the audio library directly. Because trying to do it this way is just going to add a whole bunch of complexity that I'm actually trying to avoid. We might add something later to identify these, but I don't really want to do that. Does it have a fade in, fade outs? No, this won't. No. And again, if that's something you need, like maybe we could extend this in the future to add that kind of stuff. Although we could also argue that this is where the action cue could come into play. So maybe there's a sound fade in action or sound fade out action or something of the like that takes in an audio instance. And it's responsible for, the playing and the stopping and the pausing or the fading in, the fading out, applying effects, that kind of thing. This is really just meant to be like, I opened my inventory bag and want to play a sound. That kind of thing. This is not meant to be like anything super hardcore, I guess. The only thing I'm thinking about... Yeah, anything you want to do that's more complicated, that you should really grab one of these instances and do it through that for now. Yeah, I think that's going to be the way to go. Because just trying to think my way through that, like, it just adds a whole bunch of complexity that we really don't need for something that's largely going to be an exception case. All right, good call though. But yeah, I think that's the way we're going to go for now. All right. So I guess we probably ought to figure out like what this configuration ought to look like. And I think it's going to be pretty straightforward if we're honest. So in our K app, let's see. You know what we could actually use is I feel like I could use the app config, but I feel like that's going to bloat the app config. So maybe I should just not do that. Let's do configs, right? And then in here, we're going to do soundboard .config. Extension doesn't really matter all that much, right? And then in this one, it's basically going to be entries is an array of objects, each one of which has a name, right? So let's see, what was the sound that I put in here? Pretty sure I added it. Didn't I? Did I not? Wait a minute. From that dash A002. Okay. Oh, why wasn't I seeing that? Why wasn't I seeing that on my search before? Am I just losing my mind? KF. I guess so. All right. So this essentially is just going to be, dash a, whoops, actually, no, this could be anything, right? So let's say sword swing, just to make it different. But the actual asset name, right, is going to be dash A002, right? And then the package name, if provided, is just going to be, right, which default, I'll probably just say as well, it just defaults to this package. And so all of our entries would essentially look like that. I don't know that we're actually going to need anything other than that. We could put some other settings in there, though. Such as, we could do something like that, right? So we could say, we don't want this thing to loop. I don't know how crazy we want to get with this, because for all of that stuff, I'm going to have to add a way to do that through code. And again, I feel like if we go too crazy on that stuff, it might just make sense to, wait a minute, what? Oh, right, because I haven't filled the C file out yet. So I guess our configuration would kind of look like this, right? I guess if we needed, technically the loop could be set per instance of it. So I guess we really don't want to do that. Same with like volume and stuff like that. So I think really for the entry, oh, one last thing. Max instance count, right? So in this case, we'll say, let's have a max instance count of 3. Yeah, that should be fine. And then if we don't provide a max instance count, maybe we just default it to 1. Okay. So that's what that's going to look like, I think. I think that's reasonable. Let's go in. And paste all this here. Include soundboard H and oops. And most of this is just going to be fairly lightweight stuff. I don't think I don't think there's going to be anything too crazy going on here. All right, so I suppose we should have a k-assert out state needs to exist, right? Let's actually split this down, and we'll say next if the config string exists, then we'll go ahead and process it, right? So we'll do, actually before we even do that, let's set some basic stuff up, right? So we'll do out state entries. We're going to do darray creates, and that's going to be soundboard entry. Right, so we have that. And then config string, if that exists, what we're going to do is kson tree from string. The source is going to be config string. And then we have a kson tree, and I guess we'll just call that tree. How original. And we'll take the address of tree here. And then if this fails, technically that's where we can have a failure on this system. So kerror, spit out the function name, failed to initialize, see logs for details, and then function, right? And return false. All right. If we do, oops, that should be a not. That was almost nasty bug. All right. So if we do get it successfully, if we do parse it successfully, essentially what we need to do is we need to get the entries from the root, right? So we're going to say kson array, I guess it would be kson object. Would it be why is it not giving me all of my not giving me all of my functions. Sometimes I have to actually open the file to get that to happen. Object, property, value, get, array. That's the one I wanted. All right, so we're going to take the address of tree.root. The name we're looking for is going to be entries. And then we obviously need a kson array here, and we're going to say entries array, right? And we're going to take the address of entries array, right? That, if that does not come back, that is a critical error. So if that fails, then let's just go ahead and do this. And actually, we're going to have a lot of points that are going to potentially fail, but only if we have configuration. So let's do b8 success equals false. And we'll use the old go-to pattern, right? So we'll do a label down here. We'll say soundboard init config cleanup, right? Down here we'll do kson tree cleanup, pass the address of tree so that we don't leak any of that memory. And if not success, then we will return false right then and there. Otherwise, we'll return true. And then right before this label, we'll do success equals true, right? So if we progress to this point naturally instead of there we go. So if we hit an error while we're trying to process our config, we just jump down here, clean up the tree, and boot out, right? I suppose we could also do, this. And then actually that would eliminate the need for that, right? We could just, bam, we could just go down there and print that out if not success and return false. So the advantage to doing that is so that we don't have to just do, clean up, return false, clean up, return false, clean up, return false every time we have one of these failures, right? We could just jump down here and we're good. So we have our entries array. The next example of the thing that we're going to have to get from that is if we don't have case in object property value, well, actually it should be case in array element, what is it, count, length? No. Element value, case in, damn it, hit the wrong key. If not, case in array, element count get, and we just pass entries array, and the out count here is going to be I guess there's a small optimization we can do here, but let's just do for now addressive count, right? So if that fails, then of course we do that, right? And we could, instead of doing the D-array create up here, micro optimization, we can say else, right? If we don't have config, we'll stand this up this way. If we do have config, then what we can actually do is instead of doing this, after we actually have the count, we can actually do D-array reserve count, right? And that way, every time we push to this, we're not allocating more memory, right? So that's just a small optimization there. We should probably also do here if let's do if out state entries D-array destroy out state entries, right? So we don't leak that. Okay. The next thing that we're going to do is we're going to loop through all of these entries, right? So once we've gotten to this point, we can do a for u32 I equals 0, I is less than count, plus plus I. Okay, and then in here, we can do a case in object, and we're going to call this entry obj, right? And at this point, we can go ahead and say case in array element value get object. And so the array is going to be the entries array. The index is going to be I, and then the out value we're going to write to entry object, right? Again, if this fails for some reason, oops. Let's see, we need another, there we go. If that fails, of course, we can go ahead and just do that. Okay. So as we progress through each one of these, we are going to have to parse properties from each one. And some of these properties are going to be required and some are going to be optional, right? So name we're going to require, asset name we're going to require. But package name is going to be optional. We'll just default to Shadows of Illumina. And then max instance count will default to 1 if it's not provided. I knew somebody was going to say something about the go-tos. Yes, but it's a valid pattern in this case. Well, I work in cybersecurity, always been extremely passionate about gaming, looking to potentially make the jump to game dev inside of sometime coding capability. Do you have any experience working with gaming studios? What is it like? What are suggestions maybe you can make to someone looking to transition? Thank you. So I actually moved away from doing it full-time because of work-life balance issues. That's probably not necessarily the issue everywhere, but that is a common issue in the industry. So heads up about that. I got tired of working 70-hour weeks all the time, right? 70 plus hours. But that being said, in terms of looking to move, the biggest thing that you can do for yourself is build yourself a portfolio of projects. Find out what studios you're looking to get into and make something sort of in that style. And if possible, using the technology that they use. So if the studio you're looking at uses Unreal, build something in Unreal. If they use a bespoke engine, build one yourself. Keep it simple, but learn how to do that, right? Because you're going to have to learn how to do it there. So do a little research on some of the places that you want or you're interested in going to, figure out what they use, and build yourself a portfolio of projects. That being said, don't be afraid to branch out and do something on your own just because it seems cool or you just want to, right? The important thing is to have examples of your work out there that are easily accessible that you can just list in your resume and say, here is my portfolio of work. Here's a link to it, or here's a link to my GitHub. Check out this repo, etc. That is the biggest thing that you can possibly do outside of, actually obviously learning all the things. Game dev is fairly large though. So do you want to do engine development? Do you want to do graphics programming specifically? Do you want to do physics? Do you want to do gameplay logic? Do you want to do all of it? Ask yourself those questions, do a little research into it. I know that's kind of high level, but it's kind of a big topic, right? There's not really one size fits all. After so many YouTube videos, it took me an all-nighter to stumble on your live stream. Thank you for your videos. They offer a lot of value. I appreciate that. Thank you. And first-time chatter, welcome as well. Go to, I'm reporting you. Go to here is just defer, but better. Yeah. Coffee Lava, how's it going, buddy? Haven't seen you in a bit. How have you been? Go to and repent, right? Do you have a defer feature in C? Maybe one of the modern versions of it has it. I'm not 100% sure. I've always just used GoTo. So I haven't really had a need to look, but that's a good question. I don't know that there is. Google's quick answer is no. They suggest using GoTos. So, yeah, probably not. Heard there was discussion about putting RAII in C. That's still going nowhere, so no worries. Yeah, I wouldn't ever use it anyways. Do you want deferred? No, I don't. I'd rather just use go-tos because this pattern literally is that's what go-tos are meant for, right? Is situations like this where it makes sense to just make a jump in your code. And, a lot of these things are jumps anyways, right? A go-to is nothing more than a jump when it comes to, machine code anyway. So it's not really, you're not really doing anything crazy. People that are anti-go-to, I feel don't really understand what it does. I know the memes, right? I get the memes and all that, but GoTo has its place. It's a tool that is in your toolkit that is made for use when the time is correct, right? All tools have a use. It wouldn't be there if it wasn't useful. All right. So we go ahead and we get the entry object. So we're going to get the non-optional stuff first. So we're going to say if KSON array, or actually it's going to be KSON object property get string as kname. We want to use the entry object. The name here is going to be name. And the value is going to be written out to, and we should probably actually take a convenience pointer. So let's do soundboard entry. We'll take a pointer to that. We'll say entry equals the address of outstate entries sub I. And then we'll just do, entry name, right? And so if that does not exist, then we are going to do a goto, but we're going to be a little bit more explicit this time, and we're going to also say property name is required but missing for entry number. And we'll just print out the entry number too so that we can actually see which one it is. Useful error messages, right? So we'll do that. What did I miss here? Oh, I think this needs to be address of. There we go. Okay, so name is required. Likewise, asset name is required, right? So this is going to be asset name, and asset name, right? So those two things are required. The next thing is, let me move this over a little bit. There we go. The next thing is package name, right? So this one is not required. So we're going to output there. However, if we don't have it, we are going to do entry package name equals kname creates package name shadows of Illumina. Right, so we'll just use that default there. And then the last one is going to be let's see, actually probably, I don't even have to, yeah. Let's see, we'll do entry max instance count equals 1. And then here we'll just do KSON object property value get int. And we'll do a entry object. This will be max instance counts. And this is actually going to read an i64, which is actually larger than what we actually store. So let's just do an i64 max instance count and read into that. Right, so max instance count. And then actually here we'll just do if we are able to successfully get this one. Then we'll basically just do a entry max instance count equals u32 max instance count. Right? And that is going to be how we're going to do that for all of these. And that is it for reading our config, right? So that's just going to automatically create all of those entries. And then once we have done that, and I think I'm only going to do this once we actually have successfully initialized everything here. At the very end, let's see, actually, should I do... I should probably do it inside of here so that we can benefit from this cleanup if we need it. Oh, there's another step. I almost forgot to. We didn't add this to our binary search tree, right? So we need to do U64 BST insert. The root is going to be, let's see, we're going to do outstate lookup. The key is going to be the entry name, and then the value is, I guess, going to be, I guess I can just do this. Right, so we want U64 to be equal to, wait a minute, the index, right? So it's going to be I. Yeah, okay. And then this is going to do, let's see, BST or BT node, pointer, new node, right? And so if we do not yet have a root, right? So outstate lookup, then outstate lookup equals new node. All right. So that's how we tell the BST about it. And then I guess it probably makes the most sense to go ahead and acquire all of the instances that we need at this point. Maybe we should do it in a separate pass, right? So we add all these things here, and then we go through, and if we've parsed all the config properly, then we go ahead and do it. So I guess let's do another one of these. And in fact, I'm going to grab that. Right? And so here, we'll essentially need to set up the instances, right? So entry instances. And since this does have a max instance count, we can actually just use a K array for this. K audio instance. So this is going to be kalloc type C array, and then this is going to be a K audio instance, right? And the count is going to be entry max instance count, right? So we're going to do that, and then we're going to loop again. So we'll do U8 j equals 0, j is less than entry max instance count plus j. And then for each one of these, we're going to go ahead and reach out to the audio system to get a instance, right? So we're going to do K audio acquire from package. So we're going to actually need the audio system state for this. So let's go ahead and acquire that once up here. Actually, do we have... Yeah, I think this is the only place we're going to need it. You know what? Let's actually cache that. What was the type of that, though? So we have engine systems get, and then asset state, right? So that was asset system state. So let's go here, and we're just going to do struct asset system state. Asset system, and actually instead of having that there, I'm just going to do struct asset system state. Whoops, get rid of that. So we'll just forward declare it instead, and then do outstate asset system equals that, right? So that way we don't have to get that a whole bunch of times. So now we can just say outstates asset system. So the asset name is going to be the entry asset name, and then we have entry package name, and then is streaming we're going to say is false for now. And then the audio space. So this is, I didn't think about this. So this is whether or not it's going to be used for 2D or 3D. I feel like that might be something we want to include in config. So like audio space equals 3D, right? Yeah, we need that. Let's go ahead and add one more property to that. So here we'll have, let's do K audio space. Audio space. Right. And so in this case, what we're going to do is we're going to do something similar to this, right? So it's a required property. We're going to do audio space, and this time audio space string, we're going to output that to audio space string. Was that not supposed to be constant? Oh, it's not a K name, that's why. Okay. So we'll take that, and then this needs to be audio space. If it is, then the next thing we need to do is say if string equal I. So audio space string, and then it needs to be either 2D or or 3D. Oops. Or 3D. So if it's 2D, essentially we're going to say entry audio space equals K audio space, 2D. Otherwise, it's 3D. Whoops. And then what we'll do here is if they pass some rubbish, we're going to do a warning. And we're going to say config for entry whatever index passed invalid audio space of, and we'll just output the string. And so we'll do I and then audio space string. And then we'll default to 3D. And then here, obviously, we'll do string free audio space string. So now that we have that, we can just simply come down here and do entry audio space, right? And so this returns a K audio instance. So this would then become entry instances sub j equals that. Now, why is this bleating? K audio system states. Oh, I did the wrong system, that's why. This should be K audio system state. Okay, we are going to need... We are going to need one more thing on the add entry, and that's going to be K audio space. We do need that. And that one was, which one? I don't think I can get rid of either one of those. Maybe I can. Okay. So soundboard add entry. This just needs to have K audio space. Audio space. We'll come back to that. All right. What does the game look like now? Not much, because we only just recently got back into game code. In fact, have I tried to actually build this yet? Or I might still be able to run it. So I've got like placeholder assets in here, right? So I have the ability to walk around, run around, swing a weapon, that kind of thing. We just recently got our animation system in not too long ago also. So like all this is like brand new stuff that we've put in place. So we're definitely in need of better assets. Like this is a placeholder asset. The animations aren't all that great and so forth, but that's kind of what it looks like so far. Placeholder everything. All right. So let's see. So we acquire all of our instances here. That way we already have them. And then I guess that's all we have to do. I don't know if there's actually a failure state from this. I don't remember if there is or not. Turn out instance. I guess we could check for this. Yeah, we should probably check for that. Oh, that's kind of annoying. Let's do... heck with it. Let's do if... that's really annoying. All right, I'm just going to do this. We'll do that, and then we'll say if instance ID equals invalid. Wow, why is my invalid ID not showing up? Invalid, there it is, U16. Or base is invalid, U16. That is an error. So that means we failed to obtain an audio instance for entry. And then we'll print out the K name there. So we can just do entry name, right? And then, of course, go to soundboard init config cleanup. All right, so we'll do that. Otherwise, then we can do entry instances sub j equals inst. Okay. Now, I suppose since we actually have this entries, we probably ought to... Honestly, if the soundboard fails to initialize, like, we probably don't even need to bother with this because we're probably just going to shut down anyways. So, like, I could go through here and just loop through all of these and destroy the arrays, right? I guess I'll just do it. U32 entry, I'll just do, entry count equals the array length. Out state entries. Oops, what am I doing? Dingus. All right, for U32I equals 0, I is less than entry counts plus plus I. And then we'll do if entry, or entries, what was that? Outstate entries, sub I, instances. Then we'll do k free type C array. Outstates entries, sub I, instances. Type is k audio instance. Count is going to be outstates entries, sub I, max instance count. Right? Would have felt weird not doing that. And I suppose I should also try to release all these audio instances, but again, I feel like that's not really necessary. Okay. So I think that's all we're going to actually have to do as far as that's concerned. As far as initialization, I think that's it. What is this warning up here? What is this? Oh, it's not asset system anymore, is it? It's audio system. And this should be audio system. That would have been nasty. Okay. So shutdown. Shutdown is basically going to be this. Right? So it's just going to be state. Followed by a K0 memory state if we really wanted to. Size of soundboard state. Sure, why not? I suppose we could also do a K assert. That state is there. That way we don't have to check that crap all over the place. Right? So that's shutdown. Again, I don't think we're going to need an update loop on this. I think we are okay on that. So adding an entry is essentially, we've actually already kind of done this. We've already done this. I guess there's two aspects of this. We're going to need basically this code here. So add entry. I'm going to have to clean it up a little bit. Right. So the first thing that we have to do here is we have to actually go make sure the state's there, and then I guess we want to do for, I guess it would be U32 entry count equals the array length states entries. Why did I do that again? Okay. I'm getting tired, I can tell. All right, so for U32 I equals 0, I is less than entry count plus plus I. So essentially what we need to do here, and I'm actually going to grab this, take it up here, change this to 0, or I'll say k null. Trying to remember to use that. So what we're going to do here is Oh, you know what? We said we weren't really going to support the removal of sounds, so I actually don't even really need to do this. I can actually just do darray push state entries, and then I guess I could just create a new entry and push it. Entry. And then the new index will be entry count, right? So let's actually do this, right? Do that in a minute. Take all of this, put it up here. Take this loop, put it here, right? And we'll do, oops, instances is equal to that. Max instance count is equal to max instance count. So we need that. And then name equals name. Asset name equals asset name. Package name equals package name. Oops. Audio space equals audio space. Right. And then here we can do that. This is going to be state audio system. Don't need that. Fix these errors just in place real quick. Wait, what? Okay, not sure what happened there. So we got that, and then one more thing here, entry name. All right, so we have the name here. I guess let's do these kind of in a better order. Asset name, package name. There we go. All right, so we set up all the instances here. Then we push into that array. And then the index is entry count, right? So we're going to do new index for that. And then we insert a new node. So we're just going to do state lookup. We could just do name. And then this is going to be new index. And again, if we don't have a lookup yet, we'll go ahead and assign that. And return true, right? So if this is an error, we'll return false here. But other than that, that's pretty much it. Yeah, that's all there is to adding a entry. So every time we add an entry, whether it be through code or configuration, we just acquire all those instances right then and there, and we're good to go. All right. Instance acquire. So this one is going to be essentially, I think I forgot one piece, actually. Yeah, we forgot the states. Forgot to set that up. Yep, forgot to set that up. Okay. We need entry instances and then entry states. And that is just going to be a Boolean. And since it defaults to false, we don't have to do anything from there. Which means we need to do that here as well. I'm just going to paste this here. In fact, and then just do dot states equals that, and max instance count right there. So when we do an acquisition, we're basically going to do, obviously we need to assert this first, and then we'll do a, let's see, a soundboard entry equals the address of. Oh, we actually have to do a lookup first. So I guess we'll say states entries index. So we'll need to get index, right? So, whoops. Keep hitting the wrong key. So U32 index equals U64 BST find. So the root is going to be the state entries. The key is going to be the name. And what does this return again? I don't recall. Oh, pointer to the node. Okay. BT node. And so we need to pass the address of that, I think. Root. Oh, it's not entries I want. It's lookup. All right, so if node, then we can do all of this business, right? So we'll say, how did I actually say I was going to store that value? I think I said I was going to store it in, yeah, this should be actually in U32, not U64. So I want to get the value out of here. So U32 index equals node value U32, right? And so there we get the entry, and from there we can actually loop through the available, or the states rather. So we want U32, or actually U8 I equals 0, I is less than entry max instance count plus plus I. And then we'll say if entry, or actually I guess we'll say if not entry states sub I, then that's the one we're going to use. So we'll say entry states sub I equals true. And then we will set out instance to entry states sub I, entry instances sub I, rather. Oh, right, we need, this needs a name too, I think, doesn't it? Yes, it does. So I guess this will wind up being a, we'll have to do it this way. So we'll do audio instance equals that. And then we'll have to do name equals name. Can I not do that? I might not be able to do that. Expected expression. I bungled that syntax somehow. I might have. What is it? Entry name, that's what it was. Entry name. And then can I just do out instance equals inst. There we go. Okay. And return true. Okay, so if any of these things aren't true, we didn't find this, or we didn't find a instance or whatever, the result of that is going to be a return false. We could be a little bit more explicit about it, right? So if we loop through all of this and we don't find anything, we can do a k, I guess a k error. Technically that's an error. So we'll spit out the name of the function and then unable to find free instance of entry, and then we'll just spit out the k name, and we'll do entry name. Otherwise, I guess I don't usually like putting else's here, but it's for error reporting, so I'm okay with it. Oh, you know what? I forgot to put function here. There we go. Let's just do this. Unable to find entry named that. And we'll just go with name. Right? Just so we've got some detailed error messaging there. And then this doesn't actually tell me when I go to free it what that index is. So I'm going to need to know that too. And I almost feel like instead of name, maybe I should just use index, but name does give me some debuggability, so maybe I'll leave that. All right, let's add to this U8 instance index, because we need that as well. I might need to find a better way to pack that data, to be completely honest. So this is going to be instance index equals I. Right. Okay. So the way that this release is going to work is going to be k-assert states, and then all we're actually going to have to do is, well, I guess I am going to have to do a lookup. Okay. So we'll do a lookup, which means I guess we'll just copy these error messages. Just really need that one. Okay, so the name here is going to be instance entry name. And that's going to be the same thing here. All right, so we have the entry here, and then we'll do the instance. So all this should really need to do is do entry instances sub instance and index equals false. Well, not instances, states. That's all it should have to do. And then we want to invalidate this handle, as we mentioned before. So we're going to say instance. I guess we could just do, this. Instance index equals invalid ID U8. Instance index entry name equals invalid k name. Instance audio instance equals, actually I guess we could just do How many times can I hit the wrong key? All right. Base equals invalid audio. Wait, invalid ID U16. And then instance ID. There. Okay. So we invalidate the handle, and that is basically that. And then the entry play is basically just going to hook into the audio system and play the thing. So I'm thinking channel play. To do figure out a channel to play on. I'm hard coding it to 1 for now. It's not really what we're going to want, but K audio channel. Let's see. Do we have... Wait a minute. That doesn't seem... Play in category. Oh, this is the one I want. I want K audio play, not channel play. That's why. Okay, so we just want... I guess we have to actually acquire an instance, play it, and then free the instance, I guess is really what we're going to look for. Which I actually just realized I'm over time, so I think I'm going to put a to-do in here. Acquire instance, play it, then free it when the audio completes. Probably need audio complete events that can be fired, because we don't have that yet. That's going to play into like the same kind of thing when we complete an animation, right? If an audio file is not looping, then we should probably have a event that gets fired when it's done playing. Soundboard going to live for the entire duration of the game? Yes. Linear search for instance. It's not that many, right? Yeah, true. Yeah, I mean, that's... I could store the index. I need to store the index, actually, because I have no other way of knowing which instance... Well, okay, I see what you mean. I could just compare the audio instance, right? But, like, the audio instance contains 2 things, so I'd have to technically do 2 comparisons. I mean, but yeah, like you said, it's not that many, so I don't know. Maybe I could do it that way. 6 of one, half does another, I think. Audio channel is like audio track and not audio channel like left or right. Yeah, exactly. So there's a number of channels that you can play of audio, right? So 8 different channels or 16 or whatever you configure. I think the max you can have is 16. And so you can actually say what channel you want something playing on. And then you have panning, which is separate from that. All right. Anyway, like I said, I'm over time, so I'm going to find somebody to raid. With that being said, I really appreciate you guys being here and hanging out with me tonight. We made some pretty good progress, I think. And we'll be back tomorrow for more of it, hopefully tying a lot of this up and getting it done, to be honest. Let me just take a look at who is out there to raid. For any of you that are new, I would greatly appreciate a follow. and or sub on the YouTube side if you're so inclined, because I am trying to grow the channel. Appreciate that follow. Thank you. And like I said, we'll be back tomorrow night. I'm just trying to find somebody to raid really quickly that's doing something somewhat related. Sometimes that's harder to find than you might think. All right, well, here's somebody doing GPU programming. C++, PBR, IBL. See what they're up to. Cool. All right, so let's see what they're up to. I've not rated this person before, but we'll see. All right. Anyway, thank you guys so much for being here. I appreciate you guys, and I will see you guys on the next one. See ya.